Oh yeah, just in time. Hello, welcome everyone. How we doing? There you go. Hey there, Paya. How you doing? Welcome. How's things been? Yeah, this is Nick Johnston. He is a legend. Oh, I think he's working on something new, or he's been doing lots of little things, little jams. Right. So, past two streams have been pretty crazy. Pretty crazy. We've been doing lots of research. Lots of just trying things out, and then we finally figured something out last stream. Well, we completed the whole bit of research last stream, so we designed the OS, the operating system abstraction, like the high level abstraction that we're going to actually use in the game for having like an input device. Whereas either a mouse, keyboard, or gamepad, and we can extract like the name, the type, the vendor ID, and product ID from it. But also, depending on what type it is, you can extract like mouse-specific information about its current position and stuff like this. If it's a keyboard, you got all these keyboard functions and gamepad. So we've wired these in at the high level. And we did also do a gamepad abstraction as well with the action and that. So we wired these in at the high level, but we are just now need to link it to the underlying operating system specific, or the specific operating system now. So we've got two operating systems to do, obviously. Today, obviously, that is basically not Windows. Oh, where's my camera gone? No. Damn it. Did he get nudged? That is a very beautiful still image right there. Right. Now the more ugly version of me is back. Here you go. And also, can we fix this? So... Right, that ought to be good enough. Oh, it's kind of coming back. Yeah, don't worry. He probably won't show up for a good while. Yeah, so we've got two OS backends to do. We've done all the research on Linux, right? That's what we've been doing the past few streams. We've got some files from a few people who can help us with the ports of Windows. So I'll be looking at their implementations of on their own code bases. So we need to hop into OSC because I actually missed something last stream. We also have an event system where we get events back, and we've missed two ones, right? Input device, add, and input device removed, something like that. Added, removed, connected, disconnected. Hey there, Ransel, how you doing? Hey there, Cormac Blue and Bub. Hey there, Bub. How you guys doing? Welcome to the stream, folks. So we need to get these guys plugged in. So we need to add we need to find the event system. Oh, and the internals, isn't it? Internal header. And we're going to add these two functions here. So this is internal, right? So that means only the stuff within inside this OS folder can use this header. So basically, for every operating system that implements this OS interface, they have these little functions here to queue an event. Maybe I might make these public if I need it outside, but we'll see. So we've got input device connected, input device disconnected. She's passing the input device, and there you go. Thank you for the follow. Actually, I don't know who this is. Should we take a look? I don't know who's singing at least. It might just be solely Nick Johnson, you never know. There's no credits anywhere, so it just must be him. Input device. Input device ID. And then you probably want to have some auxiliary information, right? Because when you connect the device, this would be a valid ID. When you disconnect the device, this is going to be an invalid ID because we would have returned we would have deallocated this input device. So what we want to do is we want to give you all of the lovely auxiliary information. So we might give you these guys, right? So device input device name, type, vendor ID, product ID. That'd be pretty nice, right? So we'll fill these guys in. We'll make these two functions now. So if a device gets connected, the operating system's going to want to feed in all of this stuff, right? So already the answer is actually all of this as input. Hey there, Glorious Sir, good to see you. How you been? You've been playing The Legend of Zelda, eh? The new one. Whilst Dad explains on the phone to Grandma the difference between my first Zelda and that stuff. I don't understand. I don't understand. Is there Wi-Fi in Zelda now? Or is this real life? Right, so here we want to allocate a new input device. So if you remember from the last stream, what we did is we moved those from the global OS structure, we moved the keyboard and mouse into an input device structure up here, right? So you can have multiple keyboards and mice, right? Or mouses. And so we need to basically allocate with the pool. So this is the best thing about the pool. It's really quick at allocating and deallocating single objects. So doing an allocation with this guy is pretty cheap. So I want to go alloc this GOS.input devices pool, and we're just gonna get back an ID. So OS input device ID. Let's call it device ID already. So we want to take a pointer to that, please. There we go. And we get back a pointer to the actual device that we can fill in. So now we can fill in that device. So now we say device name is equal to name. Now we might have to allocate. I'm not sure. It better live long enough, basically. I'm not sure how long it lives. We'll see. Vendor ID, product ID, product ID. Yes, we might have to allocate that ourselves, that name. I'm not sure. But let's do that. So now we need to actually queue the event. So we're going to get our take one I made earlier. And this is a input device connected. Now we get to fill in all the bells and whistles. Did not bad. Did more vertex data to SOA storage buffers, and happy to forget about the graphics code for now. Awesome. Hello entity system misery. Are you doing a what? ECS, or are you just doing, you know, the fat entity method? Like what approach are you taking with that? And also, it's good to finally forget about graphics code. Yep, and just do stuff. Can I share my Vim dot files? I guess it's got a whole load of Colmac keyboard mappings in it, but I guess I could share it. What thing, is there a specific thing you want, or do you just want to see the whole thing? Because I don't really have a place for it, you see. But, you know, I guess if people keep asking, I could just upload it to GitHub, right? It's probably a good idea. I could just gist it. Yeah, no problem, bub. So basically, this means you can actually refer to it as OS, right? Whereas if you didn't have this and you just did strut OS, you'd have to say strut OS, because it basically the way you can think about it is this has its own namespace. Like strut has its own namespace. So if I called it union, I'd have to rename this and say union OS, right? If I called this enum OS, that'd be enum OS. So enum, union, and strut all have their own namespaces, and type def basically, right, says type def this as that. Yeah, it's just one of those things. It's okay. ID name. Oh, I forgot the name. That's the one I was missing. Yeah, let's make that padding better. That's a U8, isn't it? Get that down there. So you think, so 16 bytes, 4 bytes, 221. That's good. So make sure we get that right. Yeah, I did that right. Good. All right, we're so now we've just got to do the disconnect. So the way the disconnect is going to work is it's going to get all the so OS input device get. So that's internal. And then what we're going to do is we're going to set this all up. So we're just going to say device name, device this, device that. And then what we're going to do is we're going to deallocate the object. So we disconnect the object. It then gets deallocated, but we have the event ready so you can view that like so. Sweet. So now we're going to try and do all the underneaths, right? With the actual sort of like operating system specific stuff. So we did a lot of research, and the methods we have to do to use that is use udev. So if we go to the test folder and view this thing here, we basically, you know, if you want to test an API and it's just directly with the operating system, a lot of the time you can just chuck in an empty C file and just have a bit of a play. We figured out the best way to do it is, so yeah, so the problem is like when we boot up the game, there's already stuff that's connected. So we have to scan over and find the connected stuff. So the best way is to use udev, and we have to like use this enumerate thing, and we have to sort of match on the subsystem USB. And the idea is we've got to go over all the USB devices, and we need to sort of like we need to find the children. Yeah, we need to look at the child of the USB device, and then do so we have to sort of like go over every USB device, and then where is it? There you go, scan child devices. This is our function. So this basically just prints out a bunch of information. But then we want to scan the child devices from this USB device that we're currently iterating over. And then we want to go over all of the children from that USB device that are either input or sound devices. Or sound devices, yeah, that's right. So we're not using sound yet, but we will be in the future. And then we go over each of these, and we basically there's properties. I remember us seeing there's like properties in there, and then we can find out whether something is a keyboard, a mouse, or a joystick, and then we can basically say, oh, we found a device. Here's the, and then like connect it. You know, then we can fire that connected event. Now I don't know how we're going to do this when the game is running. Do we just do the same thing again and do a difference between the stuff that's we have in the pool and the stuff we don't have in, like the stuff that we find, see if it's already connected and then don't do anything? Or do we simply, or is it, I think there's an event API, so we're gonna have to look into that, unfortunately. Oh, if you just look for what you do, low level stuff like you, but I'm afraid to. I want to do level stuff. I'm afraid of the job market. Don't be afraid. Yeah, the monitor API. Yeah, I think I saw SDL use that. Welcome, Akraz. Good to see you. I need to give this man a little gem. Wait a minute. He's like a guru of the Unix operating system. Already Unix, but maybe Linux. Yeah, here's a little gem. Right. Yeah, Silo. There we go. I've got scratches on my phone. I can barely see your name. Yeah, don't be afraid. Like, you know, I used to be really scared at streaming. Like so much where I was like paralyzed, I could barely talk. But as I persevered, things got better. You know, you will get rejected. You will get people look at you funny. You will get people who think things of you when you apply for a job. That's just the way it is. But you will get better, and you will eventually get a position where you would love it if you keep trying. And think smart as well. As you do these things. So yeah, make cool little projects and put stuff on your CV. and keep going around the job market, and someone will give you a chance. And then, yeah. They used to work out on stream, exactly. Yeah, I used to have those channel points. I stopped those off, but they used to be like when people save up their channel points, they can get me to do like push-ups or basically just squats and like lifting my weight. Yeah, that was good. Good times. Those are good times. I think what would happen is people would like raid me, and then like people go crazy with the workouts, and I'd accumulate like all the stuff to do, and I have to sort of like do it. It's just insane. Those were the times. All of my weights are downstairs now. That and also like no room to do anything in here. But yeah, this kind of low level stuff is very niche. There's very rare jobs in it. That is kind of true, but they do exist. And if you don't like, if people like stopped, like, sure, fair enough. Like, find a job where you can get money, and be secure. There's no problem in that. But I think being able to spend the time and to transition over to something you really want to do, like low level development, is good, because I think if no one did that, then the jobs will stop existing, and then if no one, um, yeah, it's just like good all around. Like, and the more people that try and look for these jobs and get into it, the more people that get into low level development, the more companies that get started, the more people that get hired, the more jobs that exist. So don't be scared at like not doing it at all. Like, just do it as a hobby if you enjoy it. But don't be afraid to make it a full-time job thing as well. But it's all fair if you just want to do it as a hobby. That's all good too. But yeah, if you more people can get into it as a job, that's even better. Um, you know, it might come late for you. You might be like, you might work on an open source project, and then people really like it, and then you get hired for it, right? There's all different ways of entering this sort of thing, right? All right. So the plan is we need to now get into the Linux OS implementation. And there's an OS initialize, OS backend initialize. You got to initialize that backend. And basically, after we open up we could do it here. After we've initialized all the X things, let's do that. We're going to go and call a function. Should we call a function? Or should we do it all in line, like a G? I could call a function like initialize devices, but it like only gets called once, right? What's the point in that? So we're gonna go ahead and go into the test thing, the test folder that we made, that test application, and we're gonna go and grab all these bits and bobs that we want. But also, we're gonna go back into that test thing and run it, so we can see all of the lovely information, which is going to help us actually figure out what to do. So notice here I've got this optical mouse connected, right? When we search over all the USB devices, it's optical mouse. And then we search over all the children. This one's not the one that we want. This one is maybe the one that we want. I think, yeah, because it's got an event on it. Yeah, sysname event. That's what we want to look for. And then we say, has it got the property input mouse? Then it's mouse. That's what we're going to do. I'll spend my time on work, or to work. I'll try to spend my time to work on low level. Sorry for giant text, but my thoughts are short. Sorry, my thoughts. I can't express my. I'm gonna take these off. It's getting too warm. Kind of ECS. Basically, I have a bit set typed entity buckets of fixed sizes, but I don't like it because memory is not as contiguous as I would want it. Yeah. And I want it to be, and I don't know any simple way to improve it because I can't really have end components. Yeah, I think that's kind of the problem with the entity component system is people think it's fast and data orientated, but really, you end up having lots of holes in your data sometimes, and it's not ideal. But yeah, there's you really have to think how you want it specifically for your game and stuff like that. But yeah, also just pick something that's like what I would do is just do the simplest thing that you need to prototype your game idea, and then when you need to like go when you have like an idea and what it needs to be, you would have some code that you've already written, and you can then sort of like you would have a better idea of how the data needs to be laid out for your problem. To open source projects currently I would start by contributing to open source projects currently, but I'm in a community I want to try to contribute to a game engine C++. Cool. Yeah, that's right, Pi. That's a good point. It's a good point. So yeah, all I'm saying, Silo, is don't give up and keep trying. Oh, obviously you can take breaks from the trying, but just know if you keep trying, you'll get to where you want to be. Hey there, Egotist. Hey there, Mr. Dick Still. Good to see you guys. Sleepy Rhino. Or accept the fate, do a boring job that pays well. Or that too. Up to you. But I will, man, I will. Oh, right. All inline code, just the way that we like it. So the plan is we want to go over all the USB thingies. So let's figure this all out. So here's one I made earlier. So the idea, so I need to include a udev, right? We all need a udev in our code bases. So, also they such old school. It's kind of like they do this sort of strut udev thing. Fair play. Right. So we create a new udev context. This probably has to be persistent. So we're gonna go ahead and chuck this in the Linux internal side of things, right? So source OS Linux internal. So in our internal Linux thingy, got to do more alignment. There we go. Then what we're going to do is OS backend. Oh yeah. Then we're going to make this a new enumerator using the OS backend. Got to go and prepare some. I can't even pronounce this. Right, prepare some dinner. Enjoy, Pi. Good to see you for a bit. Have a good one. Right. What is this thing here? Devices, then dev entry. Right. We'll do something like this, I think. We'll see. Okay. So we make our context here. Let's delete all this crap now. No, the device needs to stay around. Okay, so we create our udev context. We create an enumerator. We match on the USB subsystem. We do this thing, which means it's a USB device that's physically attached, maybe? I don't know. Don't quote me on this. I looked around at... I read the source code of LSUSB. Right, this guy, the thing that allows you to do this. Because I was wondering how they did this, right, this tree. And then I looked in the source code and found out, so I took their code. And then, so now we get our, so then we get the root list entry of the enumerator, and then we basically do this for each thing, which does a linked list iterator for some reason. Of the devices. So yeah, we probably don't want to run this every frame if we can avoid it. And then, so this gets us the name of, right. So I don't know why we call it name. What does this want? Syspath. Right. So syspath const char star syspath. So we get the syspath. So each list entry has a name and a value, right? It's a key value type of thing. So sometimes it has a very generic iterator interface for, and they're both strings. So we actually use this iterator thing to iterate over all the properties in the test code. Like in the test code here, you'll notice how we do for a device, we can go over all of its properties with this list entry thing, and then we use the name and get value to get the key and the value for the properties. So it's just a very generic iterator thing. It's kind of nice and simple, but it's also like strings. But anyway. So now we use our udev context with the sys path to get ourselves the device. So again, more strings. Now this can get us our vendor ID here, actually. This can be used for printing stuff, I imagine. Wait, we can get the name of the device. Yeah. All I was saying, Gloria, sir, is that just if you keep it simple, it's more flexible, and often easier to optimize later. But yeah, that's good. Because yeah. Oh. Yeah, it sounds like you're on the right track. So now this is me just having a bit of debugging, just debugging stuff. So we're trying to look for, so now we want to just scan the child USB devices. So let's get rid of that one. You have to unref the device though. Which probably sounds like deallocate in some way. Maybe it doesn't. Oh yeah, okay, it's probably like a reference counted thing. So, right, what's the next thing I want to do? So now I want to go into the grab all this child stuff, child scan, right? So we'll take all of this with us. I just put in a function for some reason. I think it's because I copied it from that libusb, sorry, lsusb code base, and then I added my own stuff in there, obviously, because yeah. Right. So now the job is to find an input. We could do sound devices in the future, but we haven't done it yet. Yeah, we're not going to do it now. But the idea is to find input devices and check if it's a mouse, keyboard, or a joystick, and then create a device added event. Hey there, Amelie. I'm so for gamepads on Linux, we're using udev to find the device, and the event is called the device node file descriptor. And then when we have the file descriptor, which is like event 15, for instance, dev input event something, then you basically read that using the read system call, and you read back structures of information. So for instance, if I plug in my PlayStation 5 controller, let me just get my USBs. So I plug that one in. Then I got to do like what's the best way to find it? Cat. Yes. So we'll find like there's event. So these are the motion, or it's a touchpad. Right. So event 19. Yeah. So I do cat dev input event 19. Right. And then I move my analog stick. Goes crazy. Oh, is that the accelerometer going as well? No, it's just writing out tons of information still. Oh, because the analog stick it's got dead zone, right? But yeah, if I press buttons, it's going to go crazy. If I press buttons. So so I'm just catting the information in here. Obviously, there's unrepresentable characters, but this is just basically structures of data where it's telling you like, oh, this button's been pressed or this analog has been moved, and you're able to read that back into the game and parse it. So we're using that's evdev. So that's evdev. It's known as. And you basically read in those structures. Which structure is it in? What structure is it again? It's in Linux, isn't it? Linux. evdev or something. I'm not sure. I'm not sure of the exact header. But then on Windows, apparently we're meant to use this raw input thing. I don't know much about it. I've just been told that's the thing we need to use. We could use X input on Windows, but apparently raw input's got less. It's got more capabilities, basically. Or is that still going? That's all good. I thought I nudged the cable there. Right, so leave that cable there for the time being. So OS backend. So child device. So we're going to call it enumerate. We're going to call it child. Child device enumerate. So we want to pass in the device. Then we want to pass in, or tell it to look for these guys, scan for the devices, so it actually builds the iterator up. Do the, oh, very error prone. Now we've got our child devices. We're going to get our, there's dev list entry, child entry. Then we're going to go and iterate over all of those. So we want to get the, this is called the syspath, isn't it? So this will be syspath, child syspath, we're going to call it, pass in the udev context. And then we've got our, right, so dev node is going to be the full path to the event file descriptor we need to read, right? So that is this one. Right, wireless controller. So it's going to have some bits and bobs in here, bells and whistles. There's 19. So 19 is going to tell us it's a joystick, right? So the dev node, which is the thing that we want, right? That's the path. We'll need that. And we'll also need someone else as well. So the quickest way is we just need to look at sys. Is it sysname? Yeah, we need to look at sysname, but really what we could do, no, we'll do get sysname. Right. So const char star sysname. So now we want to check to make sure that it's equal to event something. So we need to do a continue after this, isn't it? So if string n compare, so this is like does the string start with this? So we want to say well, we could do it, you know what, sysname 0 equal I was going to manually do it character by character since it's only 5, but maybe it's just a bit too many. Event so that will say, does this start with, right, if starts with event. And then so if it doesn't start with event, right, if does not start with event, we continue. Okay, so right, what's the next thing we need to do? So now we know this thing is it is something we can read events from. It's a device that we can read events from. Now we need to figure out what device is it. So now we need to say, has it got ID input? So there's a way to get a property. So there's a udev get property value, So child, okay, gotta be careful here. There's dev everywhere here, this is dangerous. Child dev. And the value we want to look for is this ID input. So if this exists and if it just exists, is that right? Well, it's got to be that and equal to 1 probably. I don't know. I think should we check the SDL source code and see what they do? Because they do a very similar thing. They don't do the exact same thing where they iterate over the devices like this, but they definitely look for these properties. Let's have a quick gander. Because I think they just check to see if the property exists. So vim, was it source core Linux udev? Yeah, ID inputs, look for that. Right, so they checked and they make sure it's equal to 1. And so he's checking if it's equal to doing a whole string compare on that just seems nonsensical to me. You can just do a couple of check. You can just do it's 2 bytes. Throwing that into string compare it isn't probably the most efficient thing. But yeah, anyway. So basically we just want to see if this thing has a value set. So we need to say like prop value, I guess. So we'll get that. If prop value and prop value 0 equal 1 and prop value 1 is equal to the null terminator, right? Then what we know is this is some form of input device. So now we can go again, right? We can now dig in a little deeper. So is this a mouse? I believe that was it, right? Input mouse. Look at that accelerometer. Oh, good. Input mouse. Oh, that's interesting. We need to build up a set of flags to say what it supports. Yeah, that's right. Right, so our game controller has a mouse on it. What do we do there? And imagine if your game controller had like a keyboard on it for some reason. I don't know, but let's have a think. There's a mouse on my PlayStation controller, right? Look, there's a mouse doing things. So let's have a look at that. I think we maybe design, because the idea, right, is that the gamepad, like we're combining, there's different event streams for general gamepad buttons, accelerometer, gyroscope. They're different event streams that you read in from. And, there's a mouse on there as well, so that's the 4th one. So, but my idea is we're going over all the USB devices so we can get all the ones that belong to that device and join them together in the API. So if your gamepad can have a mouse on it, it's kind of interesting. Do we just rather than make it a union, do we just make it, oh, this would be interesting. Rather than make it a union, right? Where's the bugger? Rather than make it a union and be like, oh, mouse, keyboard, gamepad, just be like, no, input device. And it could just have all of the things on it, right? Your gamepad, if it, be quite a funky gamepad. But imagine if it had like a keyboard on here as well. And for some reason it's built in. Like this API would be flexible enough for that, right? So what why don't we just make it, because we've already got gamepad flags where it says has accelerometer, has gyroscope. So now we're going to say like, we're going to call this like input device flags, and you just go has mouse, has keyboard, has gamepad, has accelerometer, has gyroscope. So now it's just one generic input device that can just do anything. So I think that'd be more interesting, and work with something which is realistic, which is this PS5 controller. So let's quickly have a bit of a gander. I think I got to rerun the. Maybe I don't. Where's this? I can't see it. Is it called touchpad or something? Input touchpad. Right, so that's different. It's not mouse. Right, it says touchpad. So I guess we'll call that mouse still. I didn't realize I had one of those. But I guess you can tell if someone is a touchpad or a mouse. Would that be useful? Well, you don't want someone to... Yeah. Right, so let's change this API a bit, I reckon. Because... So this input device thing... Where's the public API? So now rather than having this device type, instead it's going to be like feature, or yeah, I could just call it flags, right? But I could just also call it feature. Input device feature. So basically, it has a feature of being a mouse. It can also have a feature of being a... I like padding stuff, right? It's good. A keyboard. It can also have a feature of being a gamepad. And then it can also have a feature of being an accelerometer. Or a gyroscope. You know, your mouse can have a gyroscope on it, for some reason. So yeah, that'd be pretty decent. Yeah, we're gonna add more there. So, is it useful to know if the mouse is a touchpad? You know, I guess you can sort of like check, like, oh, if this is a, you know, maybe your keyboard has a mouse on it, that sort of thing. So maybe you want to check to make sure your thing is solely a mouse, or maybe there's a bit, we should have another bit for touchpad, to sort of say, you know, maybe you don't want to use this thing as a as for anything for very high precision, right? I just don't know the platform level of support for that though. Does SDL have something like that? Yeah, because if they had support for it, then it's probably quite supported everywhere. But I don't think they do. Which mouse ID? Hmm. Yeah, I don't think they do. So we might leave that alone then. We'll see if there's a problem with this design when we actually use it, I guess, and we can always make a change. But this is a good step in the right direction. So turn it into strings now. Not really possible. Neat idea. Imagine the user's reaction when their keyboard mouse stick works in game. Or just some obscure input device in general. Yeah, no, I think in general they do work in game, but it's like part of the same device. So, you know, we can know you got a PS5 controller plugged in, and that mouse is part of that game controller. So we could do some specific things, right? If gamepad and mouse do this. So yeah, it's interesting. I'm not sure if we'll use it, but I sure want to use it. You know, but part of me hopes by spending the time just to sort of put this in makes me want to sort of design a game around it in a way, you know, or you actually use it in a game and stuff like that. So, yeah. Right, so let's make the necessary changes. So we're still going to have a lot of this stuff. Like, it hasn't really changed everything. We're not going to spend all our time just changing this around, but it's just that now everything is enabled, right? Which is an interesting take. Turn it all on. Device features. So with the features, Kojima style interactions, yeah. Yup. So get rid of the flags now. Goodbye flags. So it says like has gyro. Just get rid of that now. Cool. So internally we've got this like get device and get device checked, right? So what we're looking for is like, so we're looking for a specific feature now, features, and I guess like what we want is like all of those features have to be on when you do the check, and we could give you a string. But I don't know. I had a nice error before, but not anymore, I don't think. So device is connected, we need to do feature now. Features. Right. That means this also broke, obviously. Okay. So we're gonna hop into the OS, the shared OS thing, and just take a gander and get this all fixed. So this is obviously just all features, right? There you go, that's simple. This one is about doing the checking. So we used to do a nice thing. So when we get a device internally, this is an internal function, we just want to make sure that all of the features that you requested are actually here. So we just want to say like expected features. So we can't really do a nice error anymore, which is kind of a shame because there's multiple. We could turn it into a string and spend 5 minutes doing that, but I can't be bothered. We'll just pick it up in the debugger. Expected features x. I think this will be good enough. But got x. So that will just show us all the bits and bobs. So expected features, but got device features. Right. Cool. So this one, so what we're going to do is just basically this type mouse just gets changed for feature mouse. Features mouse. Like that. Then OS input device feature mouse. There's a switch there. So good, we'll get back to that in a minute. Let's go to the keyboard one. OS input device features keyboard. Then gamepad. OS input device features gamepad. Okay. Right, so I just remembered quickly, we did have like this thing called gamepad accelerometer. Right, it's kind of not that anymore. So we've got to just change those around. So accelerometer, these guys. So really we want to take these and move them just up to the general section because they're just plop them here. So we'll just call it like we're not action value. These ones. We'll just put them in here and we'll just call it like accelerometer value, so you can just read that out, and then gyroscope value like that. So now these are just accelerometer and gyro, accelerometer, gyro. Very nice. These are now just accelerometer and gyro. Now they're no longer in gamepad, right? They're just an input device down here. Like that. And we deleted these guys, didn't we? The has accelerometer. We deleted that one. So these guys need to get moved up to the input device section. Yep. Just above there, like that. So delete the gamepad action, like so. So this needs features accelerometer, and then features gyro, like that. Just quickly look for accelerometer one more time. So we delete that like so. Delete these things. This wants features gyro and features accelerometer. So when we make an event, from the operating system, it can do the check. So make sure it's all right. Okay. So the only thing that's left now, I believe, we'll see after this, is that when we initialize the frame, we used to go over all the input devices and set them all up. But now, every device has well, it's a feature set now, really. So I think it would just be easier if it seems like it's a lot if we Yeah, I think we'll do branching code because it might be better that way. Input device, features, and OS feature mouse. Do the mouse stuff. Right. Else if we've got the keyboard. No, there's no else if. The whole point is they could be both mouse and keyboard. That's the whole point. If it's got the bit for gamepad, do the gamepad bits. And if it's got the bits for the... You know, for these ones, we're just going to set them anyway, regardless, because branching will probably be more painful at that point, I reckon. So we're just going to set them anyway. Same with the gamepad, actually. Look how minimal that is. Just set it all. Whereas this one, probably you want to do a branch to like avoid zeroing all of that memory, maybe. But maybe it's not a big deal. I don't know. Cool. So let's have a look. Any errors? There's still this error here. Features, 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 features. More features. Cool. So now we've finished that little refactor. So now we get back into actually implementing it from the underneath. So now we've made that change. An input device can be any collection of anything. So what we need to do now is we need to basically get that features thing, right? This device features. And when we're going over every single device, so we want to say here, we want to say, right, device features equals 0. So now if we come across the fact that this one is a mouse, wait a minute, child devices, no, put it in here. So we come across the fact that this one is a mouse, we figure out that way. Then we can say, right, device features or equal OS input device mouse, right? But also there's like a touchpad thing as well. I don't know if we want to handle this separately, but we did learn that through, you know, plugging our PlayStation 5 controller in, there is this touchpad one, so we'll do that as well. Yeah, so I think we also need to keep track of the fact that, wait a minute. This is all a bunch of else if. So we're going to do a bit of a thing here where we sort of get it, and that way it's all in as an expression, although it is a little bit, you know, a bit sneaky here by assigning inside an if statement, then further using it afterwards. A little bit like horrible to read, but I think it's the only good way we can kind of express it right now. So that's the way we're going to roll. So that one's also a mouse as well. Okay. We've got keyboard. Now we kind of want to go like, which one is the most popular that people are going to plug in? Or in terms of that they have in their system. Is that a good idea? Because then it can early out. Yeah. So, you know, maybe, oh, you know, it kind of doesn't matter. This is not too hot. But typically you probably want to do that. Anyway. So we basically just all those features on there, but we do want to make sure that if we get this feature, we want to know the event, this dev node as it's called, right? Because this is the whole reason why we're here. The whole reason why we're here is that we want to get this path here. This path here is called dev node. And this is the thing that we read to get the events back for the device. So we're going to need to get this, and we're going to need to store it in, so this be known as the, yeah, touchpad is going to be features mouse, because I don't know how cross-platform it is yet. But yeah, because yeah, maybe we can take a look, but like, because mouse just basically means you can get back. Yeah, maybe we can say like touchpad is like mouse and touchpad. Like, on Windows, can you get the know if it's a touchpad or not? Win32 in it. Yeah, you can always do it by the vendor ID and the product ID, but yeah, it's not a good idea. Yeah, I don't know how cross-platform it is. You see, it's easy on our platform right now, but I don't know if it is possible. There's a pointing device class. There's a touchpad thing here. Touchpad is not a mouse. Yeah, but you get tracking data for it though, right? Hmm. So I guess we could get it back. Here, there's this function. But yeah, maybe I don't know. Should it be separate though? Yeah, because in a game you kind of want mouse for precision, right, and then touchpad for. Yeah, we can maybe get this pointing device class. I don't know how easy it is to get this, but it seems possible. Yeah, no, I was just wondering, like, how portable is it for... Okay, here's the reason why I didn't do it separately initially, is because I didn't know how portable it is to know if something is a touchpad or not across operating systems. But I guess it might be easy enough, right? So maybe we should do a separate thing. Because that was my worry mainly. It's possible to use your eyes. Mouse is slow. Yeah, but then your eyes are, your eyes will go off hmm. I don't know. Yeah, let's add touchpad. Put it down here. 8. Yeah, that's kind of the question. Should the game be different about it? Because you might just want to say, so if you get the mouse position and that, they're still going to work with touchpad. But then the game entirely depends on the game though, isn't it? I guess, but so you get the features, check whether it's a game. Yeah. So I guess you can just say and touchpad API and touchpad. Yeah, so the touchpad and the mouse can use this API, but then when we end up trying to use it for a specific thing in the game, we can just check the input device features. If it's got touchpad, sorry, if it's got mouse, and we can use it for high precision, but sometimes if we don't care about low precision stuff, we can use touchpad or mouse. I think that'll be good. That makes sense. Process the eye movement like an iPad. Ah, hey, an iMouse. Yeah, the only problem with like the eyes is you need to stay completely focused, and it's very easy just to sort of like, you know. And also, what happens if you click every time you blink? You know, it does. So you got to. It's not a good user experience because there's not much. Yeah. Like your eyes are used to see, and if you use it for input, it just seems weird. Right, so we're doing touchpad now. We're doing it. I think there's a way to tell on Windows. So now what we need to have is like when you connect the input device, we need to have get the dev node. So we need a const char star mouse dev node. We'll call it null touchpad dev node, keyboard dev node, gamepad dev node, game dev, lol. So this kind of needs to be, thinking about it, these guys need to be outside of this because for each USB device, so we need to go here. So we go over all the USB devices that are connected. Now we go over their children, and they can have all of the sub devices of that USB device. We're going to be filling in these guys. Now, then so my only problem is that this mouse one. So we need to do this sort of like get checked. Do I want to do like, because this says all of them have to be enabled, or maybe you want some of them? So I guess we'll just do an and like that. Meaning when we do this mouse one, we can just say or track or touchpad. Yeah, that'll work. Damn straight. Your eyes are used to see. Exactly. When you see, Russell. No. Oh wait, it didn't come up in my on my phone. No, it didn't show up. Huh. Well, I'm glad you called that. Mouse is an input device. The cursor is a desktop concept, and they may be controlled by many devices. And the translation of the input to output delta is not linear. Ooh. Oh. Yeah, interesting. Yeah, we might be getting rid of mouse. Oh no, mouse pause might stay. We'll see. You might be able to recenter the mouse position because it might be all relative, right? Keyboard, gamepad. So now we do this dev node thing, which means we can say mouse dev node, touchpad dev node, keyboard dev node, gamepad dev node. Well, it's not gamepad. Joystick. Smile. Gamepad dev node. Then, so we're just going to say every joystick is a gamepad. I'm not sure if people would have joysticks anymore. Maybe they do. We're just going to do everything for now. Input, because I think the way SDL does it is they have a database of every like vendor and product ID, and they check that. We don't have that, and we might have to have something in the future like that. But yeah, for now, we're just going to enable them all. So the other one is accelerometer. So that's another one. Feature accelerometer. And the other one should be gyro. Oh, come on, there's no gyro? Maybe it doesn't have gyro. Maybe it just has an accelerometer. Yeah, I think the PS5 only has it. Controller has it. Okay. PS5 or GS5. PS5 controller does have a gyro. Maybe it does have gyro. Wonder how we'll get the maybe it comes back in the joystick thing. I don't know. Huh. Have to look at that. The prevent cursor, you don't care about what device causes movement. Sometimes in FPS games, you want the raw input from the mouse device. Right. Yeah. I think yeah, I think we have to wait and see, but it's not too much of a pain to separate them anyway. So we'll just do we'll expose them differently. You have to wait and see. I don't know why we don't have the gyro. Is there a ID input gyro for udev? Should we see, check out the SDL code base and see what, if they have anything specifically for gyro stuff? Do they get it through this one? Because maybe it's joystick they look under. Because yeah, they've got accelerometer in that one, right? Right, I guess we'll check out the gamepad. This little gamepad. I forgot what it's under now. Game, control. No, is it game control? No, it's joystick, isn't it? Core joystick. Wait, do we want the Linux joystick stuff? I think we might. So we want to look for like gyro. Has gyro. How do they get that sensor data? What are they looking at? Right, it becomes part of the... Configure joystick. It seems like the gyro comes in as a... this. Yeah, but they're not... Yeah, it comes in as... Yeah, it comes in as... But it seems like it comes in and on the same event as the actual joystick. So it's not in a separate event device node thing, right? And there's no... Ooh. So let's read back the data. So if it comes down on the main device... Is this the main device? Does it have a bit on here to say it's got gyro support? Doesn't look like I see anything. But it looks like it will come through there. Or maybe, does it come through the accelerometer thing? IOCTL. Is that using the old Joy API though, and not evdev? Maybe it is evdev. Does look like it. Right, so might have to leave the gyro out. You know, I'm not sure we're going to need the gyro, but it would have been great to sort of get that thing plugged in. Udev check if Go hands on PS5 controller, figured out the gyro does not work. There's no dev controller. So they say they've got this U-access tag. I don't know what that does, or which thing here is saying gyro and accelerometer should work now. So maybe it's just something implicit to do with the vendor ID and product, maybe. I don't know. It's got this tag U access. Maybe it comes as part of the accelerometer bit. But usually they're a bit different. Yeah, user access, that makes more sense, doesn't it? Yeah, good point. Right, so maybe we can try this thing out and connect it, see if there's any extra bits and bobs we can see in here. But hmm. Right, so we just removed all of these guys. Okay. So so it's like got sound stuff in here as well. I guess we're gonna look for input. So we've got this sort of like joystick thing. Like you would expect they'll do something like this, like very simple. But maybe it's done differently. This is Linux after all. Joystick, joystick. Event 19. Here's the accelerometer one. It just feels very much the same just with the accelerometer on. Wait, there's this thing called an ABS. And it says 3F on it. What is that? Because in the SDL source code, they were doing this ABS bit thing, right? So maybe we just need to check that. So we're going to look at what this means. udev ABS bit. The absolute whatevers. Like what is this thing? Because I'm sure we can read that information with udev. It's not a problem. But they're doing this sort of like in the SDL source code, right? They've got this ABS bit, and they're like going over all the ABS bits, testing if the bit is set, right? And then for the gyro, they're looking for RX, RY, and if they're all set, go over all of this, and then check to see if the sensor, if it does not report, do not report gyro if we can't read all axes. Right, so then it actually tries to read the axes. If they don't report anything back, then like fail, and then it gets the resolution. Huh. But see, I've not used this IOCTL thing yet. I remember seeing it before, but I'm not quite familiar. I know you pass in enum and you can do all these different stuff with it, but manipulates the underlying device parameters of special files, in particular, many operating characteristics. So it allows you to probably read and write various data from a file descriptor, or change attributes, that sort of thing. But there must be another way of doing this, because there's ABS bits set, right? So if we can just get those ABS bits probably. Don't know. This is in my own file that we read. Hey, they're not so red. How you doing? Right, there's the ABS bits. You can get them like that. So we get the ABS bits, and then we check if the gyros are set. That'll be it. I don't know if we want to do a read. Like, maybe we should do a read in the future to be a bit more safe, but should we give this a go, right? So I reckon what we can do, so we can get a property to get the ABS bits. If property ABS, and then you got the value back. Now the problem is the value isn't an integer. So we're going to need to turn that into an integer. So, because it's a lovely string. Is it a, is that 64-bit? 1 byte, 2 byte, 3 byte, 4 byte, 6, 7, 8. Wait. 1, 2, 3, 4, 5, 6, 7. Yeah, then 8. Right. So it is a 64-bit. So you need a U long long. So string to ULL. Prop value. There's a right ULL. Right, let's man these things. String to U. The end pointer. You need an end pointer. End pointer, so you can do proper error checking. Awesome, good to hear. Not so red. How are we doing? I'm doing good. Yeah, doing really good. Been feeling a lot better lately. Yeah, been super busy. The baby's nearing. So you know, anytime from now, really, the baby can show up. So I'll probably take a week off streaming when that happens. But yeah, so I'm looking forward to have a month off and just chilling and trying to learn something new. But yeah, other than that, things are going smoothly so far. We've just been wrestling with this, with past few streams wrestling with this input device stuff and trying to figure it all out. But yeah, we've basically figured it all out. There's a few little bits, as you can tell. We're learning as we go, but we're just reading the devices. We're currently working on the code. Is when you boot up the game, look at every device that's currently connected and see, yeah, and then connect it to the game basically to make a connected event. Base. What's all this extra stuff? High, low. What's that all about? Did they do a new into you? Into long. Did I do long? I shouldn't do long. What am I, a Windows dev? That's what I'm talking about. Then base 10. So there's a thing that comes back. So that's a U64, right? So you get your value or your flags. Now I think we got to read the thing here. So the return value, if it's set to ulong max and sets error node to range, then there's a problem, right? So maybe you don't need the end pointer. Yeah, you don't care about the end pointer, actually. So if flags equal ulong max and error no, so we not equal or not equal to E range. Okay, then we'll actually process it further. If not, we'll just silently ignore it because it could be garbage, or the user could probably edit their udev files and do something and it will crash the game, so we just want to ignore that. Elong Max not available? Okay. Right, so the thing is we now want to check the bits to say if flags and ABS RX, right? Is that how they did it on SDL? They did a test bit. Is that just... Test bit just sounds like an and to me. But it could be a shift. Do grep. Int. Yep, she's gonna have all the looks. She's gonna be good. Yeah, she's just chilling right now. Good to hear. Thank you. Well, take care of you on the whole. Want to know if the whole string was converted? That's a good point. Yes. My days. What? Oh, it's underscore bit. Wally. Oh, it's a define. Right, so they shift. Oh my days. evdev off. Right, it's a specific evdev thing. It's all about endpointer. Not equals 0, then the whole string is okay. Excellent. Yeah, I remember doing like stuff like that in the past, actually, but not exactly that. That definitely sounds much better. I've definitely checked for this before. It's such a bad API. But yeah, typically if I have a code base where I do this a lot, I will hand roll my own int conversion functions. Right, not const char. Even though you pass in a const char, it's not a const char when it comes back. Genius design. So what we're saying, if equals the null terminator, bam. Excellente. Thank you. So it turns out we need to do something insane. So what I want to do is define up here. We'll do what SDL does, just define something. Some will call it like OS Linux evdev check bit. Do we want to do exactly what they do though? So they basically take the array bit. The array of bits. My question is, SDL, why is this an array? Is that an array? Oh, so it can be really long, is it? Really? So it doesn't just fit into one U32. See, we don't even have the file descriptor open at all anyway. So instead, so it's a string, right? But the problem is the string is you need to do a reverse search on the string. So theoretically, you could probably, you know, there's 8 bits per char. You know, there's 8 bits per char, so you could know which bit to look at, get that, and then check to see if that's set or not. Right, I think we have to do that. Yep, so ours is going to be a bit different. So this would be, we'll put this in the internal. Right, check from string or something like that. So we'll have the string, we'll have the bit. And this, so the way it's going to go, so it might be similar to the way SDL does. Let's just take SDL's one and we'll, so we have it, we can look at, but I do want to, ours is coming from a string instead. So, right. So, this is doing it in terms of words. Like 64-bit words. Whereas we're kind of doing it in... So I imagine this is just doing divide by 8. Right, should we see where that is defined? I don't know why it's not showing up. But if I did it in here... I see it show up though, this sort of like ABS thing. I think it's like Linux input or something like that. libevdev, maybe libevdev, yeah. Ah, there we go. Right, in a clear genius place. So if I do ev long, wouldn't it? Evdev long. Oh, come on. Right, this is grep for it. Evdev long. Absolutely nothing. So I guess that evdev long thing is part of the SDL code base. Right, bits per long. Okay, yes, as we expected, right, it's just is simply divided by 64. So, right, ours is going to be string, so it's got to be a reverse lookup, right? So we need the string length in there, string size as I call it. So string size take, so this might be unsafe, right? So you kind of want to say string size, wait, because you don't want to go outside the range of the string, because you just go before it in memory, right? Yeah, SDL thing. It's good to know. Bit. So we kind of do like bit divided by 8 because we're doing 8 bits per character. It's 8 bits per character, right? And that's what we're indexing by. Whereas SDL is doing 64 per character, right? Per word. So we're doing that, take away 1 because it's a reverse index. You take away 1. So what we need to do is we need to make sure that, hey, make sure this, if this is less than string size, and, okay. So obviously we need to wrap little parentheses around this as well. Maybe we could just make this a function. But then it's inlined, man. But yeah, we should make this a function. Boolean. So we want the string char const char star string. We want the string size. U pointer string size. We also want the bit. As far as the bit could be quite. Oh no. Yeah. So I guess I'll just do a U32 bit index. Excellent. So we'll take this with us. Journey we've had so far with it. And we'll go and find this one. Excellent. So we're going to do the first thing and say if. So we'll do our bit word index equals bit index divided by 8. There'll be like a bit, a relative bit index right from the word. And that'll be obviously remainder. So the mod of that. So if bit word index is greater than or equal to string size, we just return false. Right, so check that on debugger nice and easy. Now the next thing we want to do is actually get the word. So we'll say U8, right? So U8 word. So 8-bit words. Bit word index take 1. There it is. So that's a reverse lookup. Now you got your thing. We just simply need to say if word and 1 shift left bit relative bit index. So that, so we'll cast it into Boolean, right? And there you go. So that's how we check to see if a bit is set. We just need to make sure we get that string size now. So what we can do is in that nice thing where we check for the ABS, we can do what SDL does, where it sort of checks for these bits, but we're doing it from our string instead. So we don't do this string from whatever anymore. Instead, what we do is we get the string size. So U pointer string size equal string len prop value. And now what we do is we say, right, if, so we pass in the string, which is the property, the string size, and the thing we're looking for is ABS RX. I'm not sure what that one is. Right, so that's just 3 or 3, 4, and 5 anyway. See, R just means relative X probably. What does that mean? Should we have a look? What does that mean? Because maybe we're looking in the wrong... It seems very low. Absolute axes. Huh. So it's got to have a absolute axes RX, RY. Yeah, apparently this is the way you check it. So we'll keep going with this one. And they obviously do some extra checking. But we'll just go as far as doing it like this for now. But they also managed to fetch, when they do it at least in the SDL code base, is they managed to also use this IOCTL, and they read out the ABS info. Maybe there's a different way we can get this. We'll have to see, but perhaps not. And then get the resolution of the accelerometer and the resolution of the gyroscope. But yeah, we'll just leave that out for now because we don't really actually need it. But it's just good to have the abstraction there, so if we do, we can just sort of plug it in, plug the rest in. So if all of those bits are set, bear in mind it should have returned a boolean. Maybe I didn't save it. Right, it's good. So if all that is set, then this one is, we've got the gyroscope bit, so we can now set the gyroscope. Gyroscope dev node. But then again, yeah, which one is this coming from? Do we know? Because it might come from a because the gyroscope could come from, like, for instance, the accelerometer thing. Or it might come from the joystick. So yeah, I'm not sure how we want to read these. We'll have to have a look. But for now, they're going to be separate. These dev nodes, so these files that we read from. But potentially, potentially they could be this. We could just have like 0 to 6 of them or whatever, and we just read over all of them. We just handle, like, the event structure we read back could be generic, and then it just means that we just handle it for every event that we read. So we might do it that way, but let's just see. So now we've got, so we go over all the child devices, get all of the potential features of this input device, accumulate all of that. So this is me printing out some stuff in that test application we made before, but we don't need any of it. So at this point now, what we know is if we have some form of device feature, we have a device we can connect. So what we should be able to do is simply call OS event queue device connected or something like this. Input device connected. So we need a name. We need, I feel like we need to allocate a name. So perhaps we can store the name inside. Alright, I got this. Been thinking about effing around with Haiku when I fix my power supply on the one of my PCs. You heard about Haiku? Isn't that the one where it's like based on BOS or something? Oh, inspired by BOS, right. That's cool. I never tried it. Yeah, I'm not sure what what stuff you can do on it. But yeah, I know they do. Don't they do multitasking differently on it? Don't know what page I was on now. To be honest, I probably close a lot of this crap anyway. Cool. So we're trying to right if it's connected. Yeah. So I was thinking about in the input device storing storing the name as a built-in sort of thing here. So we're just gonna OS input device name capacity, and we're just gonna say, well, 256. We could do 512, right? But then it gets quite big considering we want to have 256 number of devices anyway. So, you know, that kind of explodes out a bit. That'd be 256 times 256. So that's already 64K of memory. So maybe I would just have like a megabyte allocated for like, maybe not a megabyte. I'm not sure how big these tables are. Screw it, let's do 256. It'll be fine. Char name. Right. So now we can have like, so you, yeah, I guess it's fine. Name size. So we'll turn that into a proper string. Device name. So this would be like core string OS input device equal this thing. We'll just say device name size. Cool. So when we connect a device, what we really want to do is pass in. See, it's kind of hard because I'm going to get like a vendor name and like on here I can get a vendor and a product name, but I don't know how feasible that is on all operating systems, right? Maybe we might yeah. So I think we'll just have the name passed in. It will still keep the name passed in. So here we'll just do a string n copy. Then I probably want to do like copy the whole name, but copy the whole name minus. I don't think it null terminates. String n copy doesn't null terminate. I think it's one of those weird ones. Right, copy into a null terminated padded sequence of fixed blah blah blah. The name of this function is confusing. Oh, there's P. B0. Oh, wait. B0 destination size. Does it go over the memory and then go over it again? What's this thing do? These functions copy the string pointed by source to the null padded character sequence at the fixed buffer pointed by destination. If the destination buffer limit size isn't large enough to hold the copy, the resulting character sequence is truncated. But I don't understand what that means when they use this lingo. So like this man page is terrible. It's not clear if it null terminates it or not. Yeah. No null terminator is implicitly added at the end of the destination source if the source is longer than number. There you go. So what you need to do is we'll copy in one less. So we'll say OS input device name capacity. Take one. Right, we know that's more than one, so take one's not a problem. So data, so we'll copy in that. Hey Joe Mega, how you doing? So you copy in that it'll be null terminated, and then name size, take one. Wait a minute. What's the size of the string going to be? Well, no, it's just size equal. Oh, good. The string copy. It returns you a pointer to the string, doesn't it? But you don't know how much you copied. Great. So you kind of want to get like a name size equals a core min between this guy and name size. Yes. Name size equal null terminator. Oh yeah. Then you want to set the name size to name size. Cool. So when the input device gets connected, now we want to just put a nice little buffer here on the stack. We'll call this name buff. We'll give it the full thing here. And I don't think, now again, we've got to see how this works, but you know, sn printf, name buff, I think this puts a null terminator on. So we've got to think about that. But yeah, we're just gonna do ss, and that'll be vendor name and product name, like that. So I think it puts a null terminator on. So again, we've got to man the smprintfs, including the null terminator byte. I think it always puts a null terminator down. I had fun yesterday. It seemed like Vulkan validation layers were leaking, but it didn't make any sense. Then before I went to bed, I realized I didn't free any memory correctly in the Vulkan allocation callback. Oh. Yeah. Damn. Yeah, I don't typically don't wire those things up for a long time. Yeah, I typically just like wait until I've like finished something until I properly wire those things in. But yeah, because you know the code all has different lifetimes, doesn't it? Sometimes you might statically allocate stuff. Or more generically allocate it, yeah. But yeah, but those layers are so big and crazy. Like, have you seen how big the library is for those validation layers? They're like over 100 megabytes, I think. You got tricked by your own. Yeah. So have you just hooked up like a standard heap allocator to that, or have you done something special? Does it terminate with a null byte? That's all I want to know. I think it does. Does not more than size bytes, including the null terminator. If the output is truncated due to the limit, then the return value is the number of characters excluding the null terminator byte. Bum, bum, bum. So you've always got to put the null terminator in. So, wait, yes. So again, you want to take one and then just put the null terminator on at the end. Yeah, we could have done it. Yes, you'll get like a. So all you want to do is just make sure you say name buff. Like that. So then finally you can just put name buff in there. Ta-da! So the question is it saying excluding, right, core string name equal core string name buff name size? We've got to work that out. So how's it going to get the name size? The problem is it returns null, including the null terminator, it doesn't get exceeded, but if it gets exceeded, it returns it without the null terminator included. So I guess we need to get a name size. And then we need to, so the problem is if that is equal to this, right? Name size. Wait, so if it exceeds that, you need to. Whereas if it doesn't exceed it, you need to take away one to exclude the null terminator, something like that. Okay. Yeah, I'm not sure if I want to include the null terminator. You know what? No. Let's always include the null terminator in our string sizes, I reckon. Yeah. Makes it easier when you want to do the allocation because then your note's in there. Whereas if the null terminator is not included in the name size, then it's a bit iffy if it's there or not. Right, so pass in the name there. So if the name size includes the null terminator, then do we need to take away one here? You've included the null terminator. Yeah, because you're including the null terminator. Awesome. So what is next? So now he's passing the features. So there's device features that we've got. Also the vendor ID, we'll get that. The product ID. Cool. So we're gonna go ahead and fetch those. So up here we went and got the... Oh, we're inside the wrong loop. Damn it. That would have done it like so many times. It would have done it for every single sub device. Cool. So I reckon what we can do, take all of this, and if it's successful and we want to add it, get all these guys. Oh, how aren't these integers already? Yeah, I guess we'll, what is the null vendor ID? Is there a null vendor ID? There must be. Look into that. I thought a certain strut deallocation when dropped, but no. Oh, strut deallocated when dropped, but no. Oh, okay. All that RAII, eh? It's connected to my own allocation system, but certainly it's just past the system allocator. Cool. Just use F sanitize address. Get a leak with. So I'm gonna do a physical device enumeration. Well, have you found one? You might be a good idea to report to the GitHub issues. Call them zero terminated strings. Yeah, but null is zero. Yeah, but the point is the null terminated character is zero, right? But yeah, but zero terminated just sounds... Yeah. Yeah, it's weird. I don't know. Yo, is there like a... Is there a sort of null vendor or something? And also, these vendors are totally going to run out. There's only... Yeah, but null terminated strings just means... Or like a zero terminated string. Yeah, true. It does sound... It's a bit wrong, isn't it? But they mean zero in terms of memory, but not characters. Yeah, it's true. Yeah. Yeah, that's definitely incorrect sounding, isn't it? Now the question is if 0000 is not. 001, Fry's Electronics, great. But I don't think there is anyone assigned to 000. So my thinking is, well, there's a null vendor. I have no idea, but let's just assume there is a null vendor. Set it to 0. So U16 vendor equals 0. It can't be U16 though, it'll have to be int. Then we'll say, so if you look at, if you man string to I, is that right? String to I is probably not good, string to U is probably not good, so you have to do U long, UL. Right, so it's got to be a long. We'll do a U long. We literally just did this, a string to UL. We'll get one of those char star endpointers. So address vendor ID string, endpointer, and base 10. Vendor if vendor equal u64 max, or and so if you didn't read to the end of the whole string, you probably want to ignore it. Also, what does the vendor ID look like? Should we have a look? ID vendor property. So it'd be base 16. Oh shoot, we didn't turn that into base 16 from a string into a crap. That's incredibly wrong. Yeah, that might be base 16, but this one, when we did this check bit, we want to get it back as a char and then turn it into a so if I want to say if the char is and nine. Then we want to say word is equal to char take 0. Is that right? It's man my ASCII's. Yeah, 0. Good. So there's an else if though, because it's hexadecimal. A to F. So you want to take away A with a base of 10. Cool. Right. So that'll get you your word. So it'll be 0 to 5. There you go. Oh, and you also want to do capital. There you go. Sweet. Alright, back to here. This one needs to be converted from string. So I guess if it's equal to that or dereference endpointer equal null term, we'll just set vendor to 0, right? And we'll do the same thing for product. Yeah, thank you, Joe Mega. Thanks for catching my back. Let's turn on. Yeah, Fry's Electronics just got 1. It's great. Oh, Intel got 86. That's great. And 7. That's amazing. Yeah, but you know, like there's only 65,000 vendor IDs. Like that's so gonna run out, right? Isn't it? Do you reckon it's gonna run out? It's one of the things when people complain that modern games require AVX. And they say that an i7 from 2009 can't run it. Yeah. I don't know, I hear so many mixed opinions about AVX, you see. So I hear opinions about AVX. What do I hear? I hear it's good. You know, it's either bad in hardware. You know, it's very inefficient in hardware, and also here it's fixed now, but some people say it's still not fixed. So I just don't know what to think about it, to be honest. Yeah, it's getting removed from the future chips. That's what someone told me the other day. Yeah. Yeah, it's AVX2, isn't it? But not AV. It's AVX 512, whichever one that one is. But AVX 256 is fine, isn't it? It's just the 512 one is a bit of a bugger. Right, so I think we got all of our things now. Right, so this should be the code. Right, been pretty incredible. So we hit the compile button. Just got to get it compiling, and then we'll go into the main file, and we'll test printing out all the devices that are connected, and we pick them up and see what features they've got, which would be quite fun. So assigning core string convertible from this. Okay. So this would be core string device name size. Okay. This one will be. So we need the device passed in. Interesting. We don't have any of this set up yet. This is going to get commented out. All of these OS events, they are in progress now. Like all this mouse stuff, keyboard stuff. Oh yeah, we started playing around with this generic event thing. I think was able to get X input to work. Yeah, that's right. Reset the keyboard codes on my days. I don't know if this is all going to work. Oh boy. Okay, undefined reference. Excellent. So what we can do is just go to the build script. This one. Gonna add a new library. Oh no, wait. Add a new library. So -l udev. We might want to -l evdev. I'm not sure. All right, that's good. So apparently we should get some events now. So we're gonna hop into the main file, and we're going to go to. So we're gonna add some in. Right, we're gonna get the. Input device connected. So we get all these things, plop those in there. And we're gonna wire these all up. So we want a device connected. Name, string, ID. Oh no, I think we don't care about the ID. It's more of a runtime thing. Do X like that. Product ID. Features. It's another hexadecimal thing. So let's plug all those in. So we're going to say event input device dot name dot data input device. So vendor ID, product ID, features. Okay. So that's the one we're looking for. We don't really have a connected one yet, but disconnected one yet, but we will have, we'll work towards that at least. So let's press the F5s and let's see what happens. So we're gonna run the game, and ideally we want to probably just exit after the first loop, right? It's all just to Linus ran it by AVX512. Hey there, Rohan, how you doing? I don't feel like they're going to remove 512, but they're going to figure out how to handle 512 less E-cores, as now that AMD supports it, they're running behind. Ooh. Also extremely frustrated about people who are ignorant about 512 and say that isn't useful, because it's just 512 wide version of AVX, like... Even check what it adds. Yeah, I think it adds more instructions to AVX 256 as well. Usually the 5, you know, they do that in. But yeah, no, obviously, like the wider the better, right? Because, well, not necessarily, but yeah, like, you know, assuming the wider you have, the more ops you can do. Yeah, exactly. All the yeah. Very nice. All right, so let's see how many devices that come up, if any. It's just probably going to crash and burn. Right, here's the crash and burn. So we got an iterator problem. 280. Right, so a thing that's to take note is maybe the dev. Did we make sure that's not used everywhere? Dev, that's fine. Unref dev. Did we unref the child device? We also should undev the child enumerate. Enumerate, where are you? This one. Bam. That is not the problem though. For some reason this for each is failing. No, this one. Why is it failing? So we can drop into the debugger, find out why. So it goes into here fine, right? So can I go until here? So it runs until they're just fine? Oh, no way. That was done inside the loop and we sort of unreferenced it, didn't we? Oops. Get rid of that. That'd be good. Cool. Easy problem. Whoa, thank you, Jav IDX. Thank you so much for the raid. Appreciate it. Welcome, raiders. How we doing? Yeah, how you guys doing? Thank you. So we're working on a game from scratch. We've done a graphics, a GPU backend in Vulkan that uses compute shaders only, but we kind of come back down to the engine side to do engine integration with the operating system. So we're just doing multiple keyboards and mice, and game controller support. Bum, bum, bum. So we're just working on gamepad support right now. Oh, sorry. We're working on reading all devices through udev and getting events when you sort of plug in the device and be able to identify each device individually and get all their events. What debugger is this? It's GF, which is a graphical front end to GDB. You can get that if you search for next GF into Google. There's a lot of front end. It's very easy to build. You can build it in a couple of. There's a very easy build script and it runs on like every distro pretty much. So go and give that a go. But yeah, so I guess I can give a bit of a show. Yeah, thank you for the raid, Javix. How did the stream go? So basically, like, I don't know, here's a video of me, past me. So we have basically like 3 different compute shaders running using a custom abstraction on top of Vulkan where we can run compute shaders. The plan is in the future is to do a 2D renderer and then a 3D renderer. The 2D is just for UI, obviously. We're just doing doing a really good job on the keyboard and mouse input and gamepad input. And then we're going to port that to Windows and then do some custom UI stuff. We also have our own custom C compiler, which compiles C to SPIR-V, so it means we can write C code and use it in shaders. Yeah, I don't know how much of that I can go into, but yeah, we have our own little C compiler. So here's a very limited example. You know, this one like clears the screen. It's just a compute shader. But yeah, it's all we use is the latest. Yeah, I don't know. I think I can just, I'll leave a link to a video if people are interested in watching it. Past me does a great job here explaining it of all the super lovely features. It means you can share code across the CPU and GPU. And just talks about different examples about that basically. So if anyone wants to take a gander, take a look there. But we are gonna, this is part of the reason why we are doing this project is so we can really write a project using this compiler and see where the pitfalls are and how to improve it basically. Yeah, it's kind of Vulkan only. The compiler at the moment is for Vulkan. But I do want to, and again, another reason why I'm doing this project is so I can also have an excuse to port it to other platforms and do a good job about it. Yeah, when the rest of the pipeline is bloat, use compute, exactly. Yeah, that's part of the reason why we're doing it is we want to see how much we can, see how good of a job we can do using just compute. And we're not going to be doing triangles, right? Triangles are they're too popular, Gonna do something else. Oh, hey Jack, how's it going? Good to see you. I see you, Tyrus Python right there. Good to see you. How you doing? Uh, it's not compiled. We're knee deep. We're knee deep in the input code right now. Nah, no voxels either. I'm not gonna. It's not. But yeah, there's no point guessing. I'm not gonna say much more. It's a secret. Right, we hit our custom breakpoint, so we're gonna get rid of that breakpoint there, so we won't hit that. Oh yeah, so we've got some devices connected. There's 3 of them, different bits and bobs. My controller isn't in there though, and the name is not even showing up. That's not good. So should we have a bit of a play with that? Why oh why am I seeing goop? So where's the breakpoint need to go? Should we go here? And then go into the GFs. So what does the vendor look like? Linux. Okay, product. So surely name should be a combination of that. Yes, it is. So when we, oh, I just skipped it. Right, we'll go to the next one. So let's look at name, generic, whatever. Okay. So that should have copied it into the device, right? Exactly. What's name size? 25. First of all, it didn't include the null terminator. It's a little bit off, but still, it should work. Oh, right, the name. Okay, I see the event is getting that name and not the new name. Right. So it's going to take one. It might be a bit wrong. Oh, we good. Thanks. Been super busy since I moved to London. Awesome. Good to hear. Yeah, I've been good. Oh yeah, there is samples on the repo. Why got disrespect, Brian? Yeah, Brian. Yeah, the guy at Epic. Then yeah. Triangles are solid. Yeah, I've watched this video many times. It's pretty fun. Pretty fun. He's got his like triangle t-shirt on. Yeah, it's great. Oh, they are wrong, aren't they? Oh shoot. Thank you. The worst kind of logic is Boolean logic. It's always the wrong way around, you know? Yeah, I've been good. Just been preparing for the baby, you know. Baby's coming. Anytime now. But yeah, I've been busy working, preparing, and that's about it really. But yeah, things are going well. Yeah, it's good to hear you've moved down to London, Jack. It'll be good to start the meetup again soon. Yeah, and also it'd be good to get it going consistently again. Oh yeah, I broke my compute stuff. Effectively, when we first tried to do, I think it was like the unsigned integer to signed integer sort of SPIR-V instruction got buggered, and it screwed up my SPIR-V binary. Ugh. So we had to go and wrestle with that, all because Perry wanted triangles. Damn it, Perry. Ooh. Yeah, backup copy almost ready. Exactly. Oh, great. Just gotta learn C first. They're starting the 8086, you know, sorry, 6502 assembly, you know. Yeah. Device. Ooh. Device name size. All right, that'll be much better. So now when we run it, there we go. So here's all our bells and whistles. Now what you can tell, we've just got a ms and a kabur and a h. You know, so clearly we take away too many ones. And I think that was in the OS Linux side of things. So I thought this should include the null term. So we're gonna, you know, we'll get the breakpoint back out and have a little bit of investigate. Hit the trap. So 54. So we should be able to look at name buff, and name buff says we've got a full controller, not controller. But is that right? So what is name then? We've got a controller. So we go into here. Oh, then that's 53. I thought I wanted to include the null terminator. Yeah, so it includes the null terminator, but then you... Oh, the string functions in C are so annoying. When they place an null terminator and don't place a null terminator. I should write my own little wrappers. It'd be way better to work with. You know, but it's, should I do it or not? Now. Good to hear. Yeah, we should restart the meet. Yeah, it's good, man. I was having so much fun talking. So yeah, there's possible side channel attack, but let's be honest, possible things. Right. Yeah, I haven't spoke with Micah for a bit. I wonder what he's up to. Yeah. I haven't seen him stream him. Yeah. But to be honest, I've not been checking, so there we go. Maybe that's that. So the problem being, so that's the size of the buffer, then if you overflow that size of the buffer. So you don't know how much you've written? So you basically just want to do that, and then always just do name size that, and then the result is always this min with that, because it will include the null terminator, right? Because the null terminator will be at the end. Okay, rocket science, we did it. Oh, we didn't do it. Let's do that, see if that's the problem. Okay, so that didn't... So have we not got the null terminator in on the... So that's meant to include the null terminator, unless you hit the end. Of the buffer, which means you would have upped it by 1 anyway. It's meant to be including the null... Oh no, sorry, wait, it doesn't include the null terminator. It just doesn't. Right, so we can always up it by 1. Oh, that's it. Okay. There we go. Cool. So now we've got these in. So now I'm going to plug in the PS5 controller. This is where the fun begins. So one thing to take note of is let's just quickly check these. So we've got these product IDs and vendor IDs. They look okay. You know, I guess we're not check them. We can check them against our other program in a second. But there's these features. So there's 3. Like, why has this come through here? And why has this come through? Has it had like a bit on it enabled? Yeah, so we'll look at that. This shouldn't be null, but for some reason it is. Right. Where's our test program? So where's the optical mouse? This one. The one in front of my face. It doesn't tell you the vendor at all, like in string form, that we can tell. Okay, that's fine. Cool. So we want to say, run it now. Do we get the... Also, we get a 3 there, so one... So this is both a keyboard and a mouse. Apparently, this keyboard hub. Oh. The keyboard hub, interesting, has a child which is the keyboard and the optical mouse attached to it, meaning it gets the bits enabled for it potentially. So we'll look into that. So now I'll run it again, and now we've got the game controller. This is where the fun begins. And now you notice it's got these features, 1C. So we go into the thing here. What we've got is okay, so we basically had this input device, and it was either going to be a gamepad, keyboard, or mouse. And the gamepad could have a gyro or a accelerometer. And was like, okay, that's probably a good abstraction. But then I realized, hang on a minute, a PS5 controller has a touchpad. So then I was like, you know what, let's just make the input device a generic thing. And so when you refer to this input device, you can get all of its features under the same ID. And that could be a mouse, gamepad, keyboard, accelerometer, gyro. And so basically it's just one big ass structure with a feature flag, and the feature flag looks like this. So 1C, look into that. One, oh, it's decimal on it. 1C. So that's, so it's not mouse, not keyboard, but it's gamepad, touchpad, and accelerometer. So I didn't pick up the gyro for some reason, and that's probably because it was in the else statement. But it'll be good to sort of see what. It'll just be good to look at that. Right, can we do this? Because I think the gyro is kind of like, yeah, we'll look at that. Okay. So let's see if it gets gyro now. Now we've got 1F, right? And that's one more bit, which means gyro. Actually, no, what's this one? This has got all of the bits. So this is obviously some root USB thing, because it's got every single thing that's probably connected. And then they said 1C. So we did one... Oh, it was 1C before anyway, wasn't it? Yeah. Oh, why didn't it see my thing? We'll have to see what this looks like. So we'll take a look, right? We'll do a... We didn't even hit in here. There's an ABS property, isn't there? Sony controller. Oh, come on. Alright, let's do a reset. Are we clear? So we're on the test program, which just scans everything and prints it all out. Oh yeah, that's probably not right. Thank you. Yeah, so we've not wired these dev nodes up yet, but that's definitely not right. Thank you. Um, So it's doing the DualSense wireless D3. 3 was it only has X, not X, Y, and Z. Right. Oh wait. 3 is the lower 2 bits. So it has X and Y. I don't know why it's not picking up the gyro. Oh, this one's interesting. 3F. It's got like all the bits on we want, right? F is all the lower one, right? F is 4, right? So 1, 2, 3, 4. Then 3 is the lower 2 of the next nibble, right? So it's that. So it's all of those ones are on. So this is one we're looking for. But it's not got an event thing on it, right? This is part of input device 25. The input device 25 will be the parent of a event node, basically. So I don't know in what world you pick this one up. Yeah, it's the one with a 3F on it. Yeah, I have no idea how we get this gyro, to be honest. Like, how you read that out. You have to use... You might have to open up the input file descriptor for it. It's so, literally rocket science. Oh. Right, we'll just ignore that one for now. Right, so no gyro. So let's take a look at something else. Right, so we're getting these guys. I don't know why we're getting these. You would have said look over all the children. Then it would have enabled that, right? So you go over all the children, all the devices. All the child devices. See, this is the problem, is the fact that it's not a direct child, I think. So you want to see if it's direct child. So maybe I think we can try that. So you want to say device parent. Now I don't know if the get parent does a ref. I have to look at that. User include lib udev. Does not take a reference on the return device. It is automatically unrefed with the parent. Okay, that's good to know. So we can do a get parent. We say get parent for child dev. So if that is not equal, to dev. Then we continue. Let's try that out. That's the point. It might be it might be a child of a child. So let's just check if that's true. Right now nothing's happening. Because apparently that's all not true. What is going on? Oh no. Great. See, I don't have to, I could kind of like ignore these. No, I could kind of like let the game figure out where, yeah, but it's not good. Not good. We kind of want these to disappear. Like all these hub ones. Oh, there's a hub bit, isn't there? Is there a hub bit? I remember seeing the hub. You could tell. There was something we could tell if it was a... Yeah, the sysname, isn't it? Like, wait, why is it a, Isn't that right? No, because you're looking over all the children of it. And the children of it have an event of 16 or whatever. Something like that. Because it's like attached to this USB port or whatever. Hmm. So if we print out a tree, it might be a bit easier to sort of understand what I'm talking about here. LSUSB-T. So basically, right, we've got a bunch of USBs connected to which has like another set of USBs connected to it, and so on, right? So we've got dongles attached to dongles or something like this, right? In a way. And basically, this one, for instance, as an example, it might not be this one, is showing up as an input device because because the way our code works is we go over all of the connected USB devices and we say, right, does any of your children have, say it's a keyboard or say it's a mouse? And if it's true, so we go over all of them, we collect them all up and we go, great, it's saying it is. Then we make this whole device this sort of like single input device that has capabilities for mouse, keyboard, and whatever it's picked up. But the problem is it's picking up for even USB hubs, which is a big problem because obviously you can have many mice under there. You know, another thing we need to obviously do as well is, well, yeah, well, how do you handle multiple keyboards in the same thing? I don't think that's going to be a problem. So we need to make sure we pick up whether it's a hub or not, somehow. So let's run our test program again and just have a bit of a look. So we've got this Apple keyboard, I know it's great. And I got a mouse connected to it. And underneath it is obviously a keyboard as well. So the hub is like the USB hub and it sort of connects the keyboard and I've got my mouse plugged in the side. Yeah, the integrated keyboard basically into it. Wait, this one says it. Okay. USB type. Huh. If your USB has more USBs, then it's a no-no. Right? That's the way you check. If your USB device has child USBs, no. That's it. So it should be quite easy to program. Basically, we need another one of these enumerator thingies. We simply just... So here's the loop where we go over all the USB devices. Yeah, it's one of these ones. So we want to go like... So we'll put in one of these little guys. So we'll say, okay, given, so sub or child USB enumerate. So we'll check for, yeah, this is it. So we just want to check if it has anything, right? So it's actually quite easy. So it goes this for loop thing, and the way they check is if list entry is not null, and that's it. So it'll give you back null. So we just want to say like child USB devices. So if child USB devices is not equal to null, right, I guess we can just do that. Then we're just going to hit continue. So we're going to say like, you know, this must be a USB hub as this USB device has child USB devices. Now we haven't really, there's typos here. We obviously have to say it's enumerating based on matching a parent of this device here. There we go. So that parent is essential, and then we just do this USB thing here. And then, right, I think that should be it. So let's try that out. Right, well, we've got nothing still. Can we try this for a minute? All right, so we didn't undo something that we tried before. What was it that we did before? What did we change? What did I change that stopped us from seeing? Oh, is there a breakpoint? That's why. Oh, no, it's not why. That one's never hit. Okay, so we're going to take this with us just in case, and then undo. Oh, it's that parent thing. I remember now. We did this silly thing. Didn't work out. Alright, let's try that. And no. It's not worked. Oh. Oh, it's too good. It's too strong. Hey there, Jess. How's it going? Appreciate it. It's a little custom theme I put together. Thank you so much. Welcome, Raiders. How are we doing? How's it going? Thank you for the raid. Appreciate it. How did the stream go? So we're working on a little custom. Well, it's a game from scratch in C. Welcome, guys. Welcome. We're currently working on the input layer stuff directly using, you know, udev. So we're just trying to sort of get game control and also multiple keyboard support into this game. So we're plugging in. So we're just, yeah. So it's a bit of a, yeah, it's a bit of a difficult one. But yeah, so we're currently we have a. What we're gonna do. Here's the best place to show you. So currently on this project, this is past me. We have like a Vulkan abstraction layer on top of we have an abstraction layer on top of Vulkan, and we have the ability to run like 3 compute shaders on top of each other. But then, so I want to do some graphics R&D, but we don't really have like the core part of the engine together. Like we didn't have custom allocation or any like array like classes or anything. So we've gone and put those in, and now we need a way to sort of receive input from the keyboard. So we've been working on that system now. But I kind of got detoured in wanting to add like multiple keyboard support and also multiple controller support as well. So we've just been working on this now. So yeah, that's what we're up to today. And we also have our own little custom C compiler as well that compiles C to SPIV. So we can write our C code. So we can write our shaders in C basically, and share like structures and functions across the CPU and GPU. But yeah, that's about it. So if anyone has any questions, just yeah. Wait, I did actually have an effect on the. Yeah, I think you did have an effect. Well, yeah, I think it kind of was because it's something I hadn't done, but also I wanted to add game controller support. And then as I wanted to add game controller support, I looked into it and I was seeing that, hang on a minute, most games don't support multiple keyboards or mice correctly. So it would kind of be interesting is, can we do it? And it is possible, but it's just something that not many people have decided to do. So it's hard to find resources on. But yeah. Yeah, would be interesting to have that kind of transport when writing something like OpenCL. It's always a pain for me. Yeah, I've not used OpenCL much, to be fair. I can give a link to the project if anyone's interested. Does it show up with that? No, it doesn't. Damn it. There we go. So there's a link to the GitHub if you want to check it out. But it's mainly just for Vulkan. I've not tried the OpenCL side of things. But yeah, we plan on just using compute shaders and not using the traditional pipeline for rendering, just because we want to try and see, how much can you do graphics without it, because currently the graphics APIs are really overcomplicated, and it would be interesting to see if you don't really need all that extra stuff. If you perhaps did a custom way of just did everything custom and from scratch. Just wanted to know because it seemed I have an uncanny ability to derail stuff by start talking about some vaguely related stuff. Yeah. Yeah, I guess it kind of maybe had a bit of an influence on it, but I'm not sure. Yeah, I think maybe. I don't think I wanted to do the full thing you was doing, but then I've sort of ended up probably getting to the same sort of layer, really. But yeah, it's all fun and games. It's good. Oh man, I'm getting so tired. What is So we're trying to detect whether or not we've got a USB hub connected. So we were doing it by. So should we print out these guys and see what happens? We can get like the vendor name. So should we just quickly enumerate? And just see if we can do this, right? Print S new line vendor product. Okay. So I just want to say like found this. Come on. Right. So it's difficult to say. We need to really actually probably tab this in, right? Found child, tab. And then we probably need to also do something like, wait, that's for dev. So this needs to go here. Just incredibly temporary code. Okay. And then we need to quickly get the child device. That one. Where's the system path? This one here. So get the new device and then get the stuff for it here. Okay. Oh, the child one has been tabbed as well. Let's just get them sorted out. Okay, here we go. So now we know that this host controller, it has all of these USB, and you know, there's some hubs in here. But the Sony controller finds itself. Is that finding itself? But yeah, we want this one to show up, right? Here's our keyboard. It's finding itself for some reason. Yeah, they're always finding themselves. So, okay, we're on the right track then. We just have to skip to the next one. First entry, list entry, first entry. There we go. This must be a USB hub. There you go. And there we go. That is it. That is it. So I've only got a USB mouse plugged in, my Apple keyboard, and my PlayStation 5 controller plugged in, and they're all showing up now. So as connected. Excellent. So now I'm going to plug in another keyboard, and we're going to try again. I don't know how many USBs I have left. This is very sketchy. Thing is, if I nudge a cable... Ugh. There we go. Should all be plugged in now. So the problem is if I nudge a cable, my sound likes to disconnect. So there we go. My camera's plugged in, I swear. But yeah, no, it's because I searched for input devices. But yeah. Sadly, the ability to derail people also works on myself. For example, when I tried to get triangle render on DirectX 12 and Vulkan, still not using descriptors yet, I'm derailing it by reading through the entire descriptor buffer spec. Amazing. But to be honest, descriptors is always, you know, just doing the standard descriptors where descriptor buffer requires a lot of reading anyway. Yeah, the chunked spec. That's what it's all about. You have to be in the know about that, you know. It's all about the chunked spec in Vulkan, because then it just loads a single page at a time. But yeah, they don't default to it in searches, which is like really annoying. Right, so now I've done it again. Here's my lovely Corsair keyboard showing up with all its wonderful colors. So yeah, that's really cool. So we've got input devices being plugged in. Although, is it saying it's got a mouse? Apparently my Corsair has a mouse. A moose. Yeah, the Corsair mechanical keyboard is like, I have a mouse, bro. Do you? My keyboard has a mouse and I can't even see it. It must be just built into like some of the controls or whatever. You can do some stuff. I had no idea it had that. Fair play. Right. It doesn't matter. It has mouse capabilities apparently. Cool. So that means the next thing to do. That's pretty decent. We're able to now go over all the devices, all the USB devices, skip USB hubs, go over all of these, find gamepads and keyboards that are connected, and then register them as connected. Now the thing we have to do is do the whole event API. It's called monitor, as it's called by, as Akraz was saying. There's some monitor API. Uses kernel U events and udev event. Sorry, access to kernel U events. Okay, so we probably want to have something like this. So we'll just probably look at the SDL source code and see what they do. But then again, theirs is probably going to be different because for us, we probably want to do a search for for every USB device connected and disconnected, not the event ones. So yeah, it will be different. So we'll probably use this, and then we can do all of the connecting and disconnecting live, like hot plugging as it's called. Is looking at SDL cheating? Not necessarily. Just to see what APIs they use, because looking at the documentation is just difficult. But we don't use the same thing as they use. Yeah. Yeah. So we just do our research, right? We do a Google, and we also look into the SDL source code as well, just to see what APIs they use. But yeah, I've been doing all sorts. Yeah, like to do the whole sort of like keyboard stuff, to find how to do the keyboard, to find where it's possible to read keyboard events. Like we did that all by trying to Google, test out different APIs like X keyboard, X input, and then we finally found out you can use X input, and then we found out you can like get the device node as it's called. But yeah, sometimes I just know where code is, and in this case I know that SDL2 uses this code anyway. So it's just a sample of how to use the API, so it's not necessarily, you know, like it's copying. I use small Rust crates. I use a small couple of Rust crates, but for my engine, I'm a graphics and OS API purist. So I do the binding in Rust for myself too. Yeah. Um Yeah, so we just gotta. So I guess like some of this code that we've written today, some of this code here, is gonna be reusable in some way. Like we're probably gonna access to like a device, right, from that monitor API, and then we can basically use that device, pass that device into a function, and do all of this lovely stuff, right? Possibly. Oh wait, this device here, and then check over all the children. Yeah. So all of this is probably gonna be in a subfunction somewhere. Right. I'm getting super knackered, but so the next stream is on Thursday 6:30 p.m. GMT, and I also stream on Sundays as well at 4 p.m. Yeah. So find someone to read. Man, I'm so tired. I keep raiding TCAP. Let's try and do someone else today. Is there any CPPs anywhere? There's CPP here, but it's Unreal Engine. Where's the real engine? Do 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 do. Hey, there's me. Do 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 do. Rust Web Game Dev. Oh no. Hey there, Basandra. How you doing, buddy? Basandra, look what we got working. I've unplugged my game controller now. Can I show you, Basandra? Look at this, man. Oh, control. I've run out of USBs. Well, I've not really run out of USBs. Wait, let me hook it into the back. Into the back of my. Maybe into this keyboard. You ready? Right. So when we run the game, only when we run the game from the boot. Oh, I don't think my thing's got enough power. You forgot to license it with Apache? Nice. Why not MIT? You like the Apache better? Do you like the helicopters better? Right, you ready, Basandra? Watch this. Oh yeah. So we got, when we run the game, we can detect that we've got a PS5 controller plugged in. We've got a keyboard plugged in, a mouse, and another keyboard. Right? So we're en route to multi-keyboard and multi-gamepad support. So we just got it detecting when you plug it, when it's already plugged in when the game boots up. But in the next stream, we're working on making that hot pluggable, right? So you can hot plug it. But yeah, it's gonna be good. Gonna be good. Right. I think I got to raid a CPP person. Oh, people don't have C++ tags anymore. Plus plus. Plus plus. This person said what? I am confused. I thought I saw Patchy seems to be like MT, plus you need to mention state changes. Something pattern use. Fair enough. No one knows CLC. Yeah, no one sees anymore. They don't see. Is there a decent Rust dev going? Let's show some Rust love. So France, France, a lot of French Rust people. What? Why is it like? Right. Okay. Just two French Rust people. Right. Okay. So no Rust. Right. Go back to TCAP. Right. So I'll see you all on Thursday, 6:30 p.m. GMT. If not, see you on Sunday. And if I don't see you then, have a great rest of your week, guys. Thank you for coming. I'm so tired right now. My brain is like fried. Ugh. But yeah. Next stream we're going to work on hot plugging support for these devices, and maybe start on the event processing as well. But yeah, awesome. Good to see you all. Right, catch you later. Bye bye. No worries. There's no need to apologize, mate. In a bit.